Okay, welcome to Hack Miami. Today we have hacking serverless applications with Tal from Contrast Security.
All right. Hey everyone, thanks for coming. So my name is Tal. I live in Italy and I work for, well, I was born in Israel. I live in Italy and I'm working for Contrast Security. And we're going to talk about serverless, hacking serverless applications. So for whoever here doesn't know what serverless application or serverless is, I asked ChatGPT what he thinks about it. Basically, is a function as a service or anything that you don't really need to develop the underlying infrastructure, but you just need to run code. You can just use cloud compute services and run code. So that means that there are some security aspects to it that are different. So, since you are here, wanted to let you know or to reassure you that you're going to listen to something interesting. So I asked if you should listen to me, and he said yes. So I'm referring to it said yes. Okay. So if I'm asking AWS, which is the biggest maybe serverless service provider, what they think about AWS. They won't tell you that they thought it would be bigger, but they did. However, this was a few years ago, and they counted around hundreds of thousands of customers using serverless and trillions of Lambda, which is their serverless compute service, Lambda functions, trillions of executions per month. So it's pretty big. Anyone here used or his company is using serverless for some stuff? Anyone touched functions? All right, 1, 2, 3. Well, usually it's about 10% of the audience, but we're near this number. Okay, so why am I talking to you about it, other than ChatGPT suggesting that? Well, I've been doing serverless security for the past 6 years, which is pretty much like a year after it became known or GA. I started as head of security research at Vertigo, was a serverless runtime security company that was acquired by Checkpoint in 2019. I joined Checkpoint, and after a while I said I want to do something of my own, so I started my own company called Cloud Essence. And you haven't heard about us because we got acquired really quick by Contrast Security about 6 months after we started. So now I'm working for Contrast Security. I'm running the cloud native security research there. Okay, and if you're interested if you find this talk interesting and you want to find me in the internet. Okay, so why am I talking to you about it now? Well, it shouldn't have been now, it should have been before, but this time I managed to come to Miami. So serverless is a growing technology, right? More and more companies and developers are using it. It's great for developers. They just need to push code. They don't need to deal with anything else. So if I want to build an application, all right. So if I want to build an application, I have the headache of, okay, I need to scale, I need to run server, I need to host, no, you don't need that. You log into your AWS, you get your AWS credentials, whatever that is, with CLI, you write your code, and that's it. It runs whenever you want, however you want, and you don't need to deal with anything else. So you can really get value, or you can get application up and running in a few hours, really. So serverless is growing, and if I'm looking in Google Trends, you can see that it continues to grow from 2016 when it was released. This is the hole there is COVID, but serverless security is not. So people are not really interested in serverless security specifically. Then you can see here there is a constant line of 1 or 2, maybe at the peak it was 3 people. And you have to consider that at least one is me. So there is another person somewhere in the world that is also interested about serverless security. Anyway, so thanks for coming here to listen. Why is serverless security different? So I'll start by why serverless is different, and maybe you'll figure it out, and if not, hopefully I'll manage to convince you after. So the architecture is different. It's not a monolith application. It's not even microservices. It's more, you can call it maybe nanoservices, but basically it's a bunch of resources in your cloud that are not really connected to each other, that are not running on the same environment. They are running in the cloud somewhere. They don't even have to be in the same cloud. And you, as a developer, just connect them through APIs, through configuration, through a bunch of other stuff, which we'll talk about later. So basically, it looks like a bunch of resources that are not really an application. You cannot look at it as application by itself, but the combination of all of those resources and their configuration can eventually become an application. So it's different in how you would manage it. The cycle of development, this is important if we're doing security inside a company, an organization that develops with serverless. So the cycles are also different. You won't see waterfall, well, we barely see it now, but it's not even DevOps. It's really more than that. It's you can call it maybe DevSecOps, but it's really hyper agile. We're developing, our product is doing serverless security, but we're also is a serverless application, 100% serverless application, and we're pushing to production multiple times a day. The reason for it, it's very easy, because you just spin up another resource and it doesn't affect the entire system. I mean, it could affect eventually, but it doesn't interfere directly with everything. It just runs by itself. Yeah, I have to connect it to the other services or get the information flowing or anything that I want to do, but I don't have to make sure the other resources are still working because it's separate. So basically, you can run really quick and push into production multiple times a day. And if you're a security team in an organization, that could be tricky, right? Because they push into production and we're outnumbered everywhere. So how do you keep up with security? The processes, also for security, but the processes of development usually are completely automated, hopefully, because it's everything is in the cloud. So in order for you to get the information back to you or to get things help you develop, you're not going to log into the cloud and go into service, log service, and then look into logs every time you run something. So you need everything really automated. All the processes are automated and pushing back your information back to you. Decision making, both for the development but also for security, are also different, a little bit different. If it was top-down traditionally, now it changes a little bit. With serverless, we can see more and more bottom-up decision making. That means that the developer has more permissions, let's say, to push into production and take responsibility of his code and his security. Okay, this is an example of a very, very small serverless application that we monitor. Doesn't really matter what it does. It's just a graph that we provide to see all your resources, how they are connected to each other. And this is very small. You have maybe the functions, which are the compute power, the code, are the orange one, and the purple ones are the APIs. The other are other services. But you can see maybe a couple dozen resources. It's really tiny. Usually a function can run, I don't know, 100 lines of code without the imports, of course. We have customers who say they have 3 million functions, not in one account, but imagine, I don't know, I didn't count, of course, but imagine how much difficult could be to manage the security or just to manage it. 3 million resources, which are not really sitting in the same environment. You have to take into consideration that as well. Okay, so let's start talking about security. And this is why we're here. So we have a very, very simple, maybe the simplest, tiniest part of architecture in our cloud, which is a serverless flow. I have a client, could be a Postman, could be a REST API, could be a website, doesn't matter. I have an API gateway, which is the AWS version of their API gateway. Just called API gateway, and it has a REST call to my Lambda function. And then the Lambda, when it runs, it needs to get its permission from the cloud to do other stuff. So it gets the permissions from the IAM service, AWS IAM service. It gets the role, the credentials, and then it talks to a DynamoDB or whatever database. Yeah? Okay, this is serverless, but we know how to deal with it. There is an API. We have to see what's going in the API. We have to validate. Of course, this is quite easy for us to understand the security. So what can go wrong? Well, what if it's something like this? It doesn't have to be a serverless, but it's very common. I have a user that talks to an Ecodot, an Alexa, right? When I do this talk online, by the way, and I talk about Alexa, then everyone gets crazy because their Alexa Ecodot start talking to them. Anyway, so I'm talking to an Ecodot, an Alexa device. There is an Alexa skill, which is the AWS service that I built to run my application or to do something with my speech. It translates my speech into code, and it goes to a Lambda function that does the same thing. Well, how do you secure that? It's not like you're going to record yourself saying weird stuff, putting it next to the Ecodot and try to pen test it through something that you recorded. So how do you protect that? Well, there is just one place to protect it, which is the code itself. Not like regular application where you usually have the network that you can always monitor, the APIs. No, just the code. So the code has to protect itself here. And this is just one example. I gave an example. I did like a POC a few years ago. I showed it in Black Hat Europe, where I talk into an Alexa device and I'm able to perform an SQL injection. It was a POC. It's not like I did like something super crazy, but you can see it's on YouTube. You can find it. So when I showed it to people and they came back to me after the talk, each one with his own serverless type of architecture, and they told me, oh, you're right. We haven't thought that you can cause a security issue, which is by something that is not user external facing API or something like this. Well, yes, you can. So basically, when you develop in serverless application, you lose the perimeter. You don't have your API. It's not just APIs, so you don't have the API gateway where you can secure. You cannot put your firewalls or whatever IDS or any IPS, whatever system that you have there. It's not always easy to test or to pen test because you don't have the URLs. So it's kind of a tricky thing when you talk about security. The other maybe most common issue in serverless is that it is very fine-grained. You can decide that your code can do only one thing in the cloud, and if you configure it correctly, then it cannot do anything else. Even if someone hacks your application, if you configured your application well, they cannot do anything other than what's necessary for the application to run. So this is an example from DBSA. I'll talk about it later. Vulnerable by design application, but it has like 20 lines of code. So this is very common in a function to run just about a few, maybe a few lines of code. And there is an NoSQL API here, API call, which writes an item to the database. Now, when you give it to a developer, it's usually not that easy. It's usually not that small. It's usually not that clear. How do you configure the security or the permissions for this code to run in your cloud? So usually, and it's very usually, you would be surprised, maybe not if you're hacking a lot of stuff Well, they'll put something like this, which is they'll set the permission for this function to do wildcard anything in this service. Because it works, right? It works. They don't not always know exactly what they're doing or they're going to do. Maybe the code will change. Maybe they'll also need to read. So instead of dealing with everything and thinking about one by one, they'll just put a wildcard. And that means that this code can perform any action on this service. The DynamoDB is a NoSQL database in AWS. So that means writing, reading, deleting tables, creating tables, whatever you do. And the resource for it is also wildcard. That means that any table, they can create or delete any table in your cloud, in this account, in this case. So even if it's not related to the application, if this code has a vulnerability, they can access those tables. What should have been done here is that the developer should understand that put item is just one query or one API call, so they should have put DynamoDB put item here and just the table here. In that case, even if you hack the application or hack it, you get access to the code to run code. You can only perform one entry into this table. You cannot do anything else. The cloud will block you. It's not that it's not a problem if someone can write something into this database, but the impact is really, really smaller than what it could have been. So this is really nice. Think about it. If you could do that for every piece of code in your application, that's like a dream come true, right? You say this code can only write, this code can only read, this can only do that, and this can only do that. So this is really great in terms of security, but when it comes to scale, it's kind of tricky because you have code running into production every day, multiple times, and as a security people, we don't know what the code is doing, so we cannot decide that. And even if we could, this is 20 lines of code. Really, if we need to look at imports and look at multiple functions every day, we're not going to get out of it. It's going to be our job, and it's not a nice job. So you have to automate this. Okay, so let's start see how those things can get hacked and what are the problems. So event-based architecture is also an acronym for serverless. It's basically something happens in my cloud or somewhere, and I configured it to run my code. So when someone, I don't know, uploads a file, run this code. When someone sends an email, run this code. When an entry in my database changed, run this code. These are types of events that can cause your code to run. And also, of course, if those can cause your code to run, there could be some attacks like injection attacks. So, how it works. So, as I said, there is a service in your cloud or outside that I configured to trigger my code, my Lambda function. In this case, if I'm running on AWS, this code runs. Usually, it takes this information or takes this event and process it, and then interact with other services in the cloud. I get a request from the user, I go to the database, etc. What happens is when this event occurs, the cloud provider spins up a container. It's not like, oh, containers. No, you don't manage these containers. It's just an environment. For you, it's a runtime environment. You cannot even SSH to this environment. It's completely ephemeral. You cannot log in, connect to this container. You cannot do anything. You can just predefine things in your code. So you have code and configuration, maybe environment variables, things like this. You cannot put other stuff in your environment. You cannot open ports or anything like this. You don't have this. So a container spins up, runs your code, and finish the execution, and the container then is shut down. So you don't have it. Everything is ephemeral. Well, I'll put a star on shut down because for performance reasons they keep it up for a few minutes to see if it's gonna run again. They're gonna just recycle it. But basically, it's a one-time thing. Okay. So when the code is in my function, then it's also, of course, where the problems come in when we talk about applications, because developers still do put mistakes in code because we're human. Okay, so let's see how I'm going to show you some examples about how you would interact with a serverless application that is not just API. We'll start with an API because it's easy, but through other services. So I have like 3 or 4 examples, and for each one I drew like an architecture of what is going on here. All right, so here is the first attack vector is through an API. And we have a user interacting with a Slack channel, and of course there is the Slack API. So what I configured is the Slack API is going to call my Lambda function, or the API gateway, which is going to trigger my Lambda function. And of course, this function is going to interact with the database and return the data back to the user. So basically, for you, it's a Slack app. For the developer part, it's a serverless application. Okay, so let's see a demo. Sorry. Okay. Okay, so what are we seeing here? There is a Slack chatbot here, which I created. It's not AI, it's just if, but it's ChatGPT 0001. Okay, so I'm talking to it, and I figured out how I figured out it's an open CVE. Well, I figured out because I wrote it, but I started interacting it, sending it some stuff, and then I wanted to see how it interacts when I send it some code and stuff like this, and then I found out that it's vulnerable to a known vulnerability, a known CVE. So then I'm sending it some code now. Right, it's not very common. Yeah, I know. I'm sending it some code. The code is going to execute a child process, and the child process is going to run call an HTTP tunnel, which is ngrok. I don't know if you know it. It's just an HTTP tunnel on my computer where I can receive data from the function. So remember, there are no servers that you can really hack into. So you cannot do like a reverse shell because there is not a server there. The EDC password file is not interesting. You won't go there. What is interesting are 2 main things. There are a little bit more, but the main thing is the code is there. So the function code is in the environment. So if I can get into the environment, I can steal it. And the credentials of this function is in the environment. So everything that the developer configured as a permission to the function is translated by the cloud to some keys, which are sitting in the environment. And if I steal them, and I'll show you later, I can use them to impersonate to this function and interact with the cloud from my computer without anyone noticing. The chances that someone will have an alert of an IP that was changed for the API calls that they do in this Lambda function is nearly 0. I saw it once from customers that we have. I saw it once, and also it was really easy to bypass. Anyway, so I'm running some code here, and you can see here I got a request from the function back to I just did a curl here. So now I'm going to change this. I just don't want test anymore. I want to run some code, so I'm going to run ls, and I'll go index.txt, which is the file that is running. So now I'm going to change ls to something more interesting. Let's read the file. Okay, so I can do cat here on the file, and of course I want it readable over the HTTP, so I'm going to wrap it and encode it and wrap it for base64, and then I can grab this base64 data, decode it on my computer, and get the code of the function. Sometimes the code will not give you anything because it could be just code that doesn't have credentials in it or keys, hard-coded. So you won't have a lot to do with it, but you can look at it. Okay, so I'm going to decode the base64 there and look at the code. But I know that this function is interacting with Slack, right? So how does it send back the information to Slack? Through those configurations. So Slack.com and the port and the path. And now what about the keys? The keys are not in the code. They are in the environment variables. But if I can run code, I can access the environment variables. And then I can see that it interacts with the DynamoDB. Again, it's the NoSQL database. So I prepared a code that is going to do use the SDK, which is the AWS SDK in this case, and run an API, a scan. Scan API for DynamoDB is give me everything. I don't need the names of the tables. I don't need the keys if there are any. They are in the environment. So when I run this code, it runs under the same environment. So I get the both token and I get the keys and everything. I just need to know how to call them. Usually they're environment variables. So I can just write a code that uses these environment variables. I also don't need the tunnel because I have the keys to interact directly with Slack. So I just dumped all the database into the Slack channel. Yeah, okay, this is one example. It's a serverless application, but it also could be something else. I'm just showing you how to interact, what you can steal from a serverless application, etc. So this is the first one. Second one, let's see storage. This is very common. All our customers are saying, can you protect us from an S3, which is a cloud storage that interacts with the Lambda function? Because this is a very, very, very common scenario. Someone uploads a file and it runs the code. Okay, so of course we have files. It's just not running directly through an HTTP to yours, so you don't send a file to the code. The function will, what happens is that you upload something to the storage service, and then AWS making sure that the Lambda knows that you uploaded this file, and then they tell you someone uploaded a file to this storage, this file. So the code can then say, oh, let me grab it. Okay? So, but you don't own, as a developer, the connection between, so this connection between the function and the cloud service, the cloud storage service, is not owned by the developer. They cannot put anything in the middle. They can put another Lambda that checks it, but yeah, anyway. So I'm uploading a file. I have an application. I get a pre-signed URL, so I can securely upload this file to an S3 bucket, and I upload the file to an S3 bucket, and then the Lambda grabs the file, downloads it, processes it. Okay, so let's see the demo again. This is a demo application. I'll show you how to use it later. Does that mean that I'm done? Okay. So I have here like a feedback information. I can interact with the application and send feedback to the owners. They don't care because it's a vulnerable application, but they also have an attached file if I want to attach something. So if I attach the file and I saw the network, what happens is that there was a request that is going to the S3 service URL, so it's an AWS domain, that gives me a pre-signed URL. Okay, so there is and then, so I upload this file, and you can see here, maybe you can, yeah, Amazon s3.amazonaws.com, and when I click on submit, basically I took this pre-signed URL and I uploaded it to the S3 bucket, and then the function behind the scene, which I don't interact directly with, so I'm not interacting with the function directly, is going to download the file. Someone made this function vulnerable to command injection. Right, so you know those attacks are normal, but you can see how I can interact using those attacks on serverless applications. So I have, again, a file name that I can use to interact with the runtime environment of the function. And again, I'm going to send, now I'm going to do, if you go here, it's a little bit small, env, which is the command to run, to get the environment variables, by base64. So I'm going to wrap those environment variables into a base64 and send it back to me through, again, the ngrok HTTP channel. Okay, let's see. So I upload this file, I get assigned URL, I push send feedback, and it uploads the file to the storage. Then the Lambda function say, oh, look, there is a function here, let's download it, and process it. And then I got this base64 data into my HTTP tunnel, and I'm going to decode it again, and let's see what's inside. Because I said, there is the environment variables. The environment variables contain a lot of stuff. I don't need all those stuff. I can learn a lot from it. I can know the runtime, the versions, but the most interesting stuff is the session token, the region maybe, the access key, and the key ID. Those three parameters are going to let me become the function. Okay, for a period of time. This period of time is roughly 4 hours, roughly, which is enough for me to do a lot of damage before I get another session token. Okay, so I'm going to use those keys. I store them on my computer, and now I'm going to use a CLI, AWS CLI, so it's just innate, you can install it, to interact with the cloud of the development company who developed this application using these credentials. And you can see I did S3LS, which gives me all the buckets, all the storage buckets in the storage, and then I can go into one by one and see the files inside if the function has permissions to do so. If the function would not have permissions to interact with those services, I won't be able to do it. And then I'm going folder by folder, and I will get the files eventually. And if the function has permission to do so, I can download the file, edit them, and upload them back. So I can cause real damage, see very sensitive data, and you would not imagine how many buckets are open in the internet. You know Shodan for IoT devices? There is a Shodan-like website that gives you all the buckets that are open. So you can just browse and see passports and whatever you want to, customer data, receipts, everything in the internet that people upload to their S3 bucket, but they don't secure their buckets. Gray Hat Warfare, I think is the name. Anyway, I saw here a receipt, I changed it, and then I upload it back, and then I called support, and I say, hey, I purchased this thing, and you didn't ship it to me, and yeah, and then this is just an example. Okay, let's move on. Okay, so we saw the storage thing. All right, last example like this is through an email service, SCS it's called. 1 second. Okay, so what happens here, there is a service, I can send an email, right, with an attachment. The file from this email is going to go to an S3 bucket, but it's not what's completely interesting here now. Then the email is going to trigger a function and say, this someone sends an email, and this is the email of this someone, and it uploads this attachment, and the attachment can be found in this location, and I'll get back a notification, automatic notification. All of this is done by a function, which is, you guessed right, vulnerable. Okay, so last demo here. Okay, Proton Mail, because I'm secure. So I'm applying to Hack Miami, in this case, maybe a fake DEF CON, and I prepared a PDF, even though DEF CON doesn't accept PDFs, and I'm going to send a PDF to this call for papers email, and I'm going to get back an email. Well, thank you for submitting your talk, we'll take it into consideration. There is going to be a review process. So now I'm going to upload, just because I like playing with stuff, another talk. In this case, it's a malware PDF. Okay, it's just a malware PDF. So just another day with a malware PDF, and I uploaded it. But when I got back, when I got the email back, they said, "Oh, we're DEF CON, right? So you submitted a virus or a malware, and here is the proof." So they processed my file. So then I said, "Okay, let's again prepare some evil files there," and I created this code that is an exploit for a specific a serverless code, and we'll see the highlights there. Okay, again, Angro, my best friends here. Now I'm going to create a client for SCS service because I'm interacting with an email. I'm going to use the reply email for the environment variable. How did I know that? Let's not get into that. I digged in. Destination, something, and then there is another environment variable called for paperless bucket, which is where all the talk submissions are going to be stored. Oh, sorry. Jump. And the interesting part of it, wait, is I'm going to change this bucket to be public. Okay? So the bucket is secured by this configuration, but I'm going to change that. Okay, so now that I have this code, I put it in some server or a bucket, which a bucket can also be a website, by the way. So I just upload it, I wrap it, and then I upload it to an S3 bucket, and then I change this bucket to be a website. Then when I address this address of this bucket, it just gives me the file. And then again, the function is vulnerable to command injection. We have those. We just need to know how to hack them. So this function is gonna download my exploit from this S3 bucket, untower it, right, and then run Python and the code that I gave it. Okay, what does this code do? I told you. It's sending an email from their part back to me, and changes the permissions of the bucket to be public. So you can see here, I'm trying to access the same bucket here, and I get access denied because it's closed. It's secured at this period of time. So I'm going to send another file. This time it's not going to be a PDF file. It's going to be my code injection named file. Check out this crazy talk, and then I upload this file. There is a function that is processing this file, and it's vulnerable to command injection. And let's see what I can do. So I sent some notification to myself along the way, so I'll know that something happens, and I get in it, and then phishing email sent, and then after it downloaded my file, I can get bucket item. So two things going to happen here. One is I got the thank you, but I also got this phishing email, which I sent to myself, but I could send to anyone else. And you can see here, hey, from the same domain of the company or the organization, I got an email which I can check and get my money for my selection, talk selection, and then I go to phishingsite.com and I get my money, right? So, but this is the last interesting stuff. The nicest thing is that I changed the permission of this bucket. So now, when I'll refresh the page, I'm going to see all the submissions. And I'm going to see all the submissions, and I can download them, again, depending on the permissions that the function that is vulnerable has. If it has permissions to download from this bucket, I can see all the talks. I can modify them, take the greatest talk, put my name in, upload it back, and I'm going to go to DEF CON. I did, by the way. Okay, so that's that. And all right, so what else is interesting in serverless? Well, thing that you hear in the internet can also happen in serverless applications. Log4Shell was a big thing, right? But functions, well, functions have log4j, yep. And we did an exploit. I can show you. I don't know how interesting it is, but I can show you a Lambda function which by default uses log4j. This is the AWS console for Lambda, right? So I have this log4shell sample function here, and I'm going to send the target with the JNI URL. Okay, the function is vulnerable to log4shell, and so in this case I'm using the console. I can also use the API gateway to send this, but I'm going to send the JNI URL, and it's going to send me back the data. All right, the access key. So I told you I need the access key, the secret key, and the session key. These are the things that interest me the most, and I got them. So now I can use those credentials to mimic the behavior of this function from my computer without anyone noticing. Almost no one. So vulnerabilities like CVEs and known vulnerabilities like log4shell and other stuff do exist in functions. So we can hopefully protect, but also exploit them, and then of course show them how to protect them using the same thing that you would do normally, but showing them what can happen on a serverless environment. Okay, so there are multiple risks. I just show you some injection attacks. There are a lot of authentication issues. Overprivileged function is an issue by itself. Vulnerable dependencies, we talked about it. There is not enough monitoring and logging and loggings by design, by default. Sorry, you have to grab those from the cloud provider, and it's not that straightforward. You have open resources like S3 buckets, but there are other things that you can leave open. Denial of service and denial of wallet. Lambda functions run per use. So if you run it one time, you pay 0, by the way, which is very cool if you build your applications. If you run it 1,000 times, you pay 0. If you run it 1,000,000 times, maybe you'll pay like 10 cents. So you can really build stuff, but you can also, if this function has a URL which is open to the internet, I can just run calls, and it will eventually cost money for the developer. And there are other stuff. So how do you learn more about this stuff? Let's jump on this. You have two things, two open source projects. One is DVSA, Damn Vulnerable Serverless Application, is the one that I showed you here. If you go to this URL, GitHub OS DVSA, I developed it. There are some contributions, so now we have version 2 out there, and it's vulnerable by design like WebGoat or DWSA, but it has a serverless application behind it, and you can deploy this serverless backend with 3 clicks, which is very cool. You don't need to do anything. You need to have an AWS account, then you need to click next, 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 and it installs everything. But do not install it on your organization AWS account, because then I'm going to get there. And someone is going to go to jail, either me or you. And it's going to leave your, I'm joking, it's going to leave your AWS account open. So through these applications. So don't do that. Do it on sample accounts that you did just for this. Another thing that you can do is go to OS, again, the OS project Serverless Top 10, where you can learn about the top 10 vulnerabilities on serverless. It's an old version. We're running now. We're working on a new version where you can learn more. But you can learn a lot from this. It's a 40 pages document about how an OS top 10 vulnerabilities would look like in a serverless environment. Okay, just a second. If you're a pen tester or you're red team, blue team, and you want to secure, I'm showing this because it's free. We have an open source project that checks your functions for misconfigured permissions. So you just give it a destination function, and we scan it, and we tell you what permission it has and what permission, or CVEs, sorry, and what permission it should have. So you can use it. It's open source. of course, we also do other stuff that is, we have a serverless serverless purpose-built serverless security product. That's it. I'm done. Thank you very much for joining me. If you have questions, do we have time for questions? Do we do that here? Okay, if there are any questions, sure. If not, I'll be around. I'll stick around for another hour or two or so. Thank you very much.